lab is called Spectra of Light Sources, and it provides the opportunity to look at different wavelengths from various light sources. There are two parts to the lab. One is qualitative, simply looking at colors, and the other is quantitative, and gives you the opportunity to actually see and read the wavelengths from a spectrometer. Let's start with the qualitative part. Various light sources are specified, plus a diffraction grating. This is a diffraction grating slide, just framed as a slide. The first light source we'll look at is a hydrogen tube. This is the power supply for the gas tubes, and this is a low pressure hydrogen gas tube. It runs very hot, very high voltages. Keep your fingers away from it while it's operating. To look at it with the diffraction grating, simply look through the grating, and because it's a long, thin, in this case vertical source, you can see the colors of the hydrogen spectrum. The lights should be dimmed. In this room it's not quite dark enough to see the second violet line, but if I hold it here and you zoom in, can you see the spectrum? You should see red, a sort of teal, and at least one violet. Then any light source that you can think of is fair game. Don't look at the sun and don't look into a laser. If you want to look at the spectrum of a laser, the way to do that is to shine the laser onto a piece of white paper or a card and look at the spot. And there's only one color, red. An interesting source to look at is an energy efficient fluorescent. I have the diffraction grating mounted about 1 meter from the bulb, and as you can see, what's visible through the diffraction grating is a group of overlapping single color bulbs, which is kind of confusing. In order to make the spectra more readily visible, we can put a slit. This is just a slit cut into an index card. And that way you can see all of the colors contained in the spectrum of this bulb. So even though it looks white, maybe a little bit pinkish, that color is actually made up of those distinct wavelengths. This instrument is a spectrometer. It allows you to not just see the colors of a light source's spectrum, but also to measure their wavelengths. In this area here is a slit, taking the place of the slit that we used made out of an index card. And over here is a wavelength scale. It slides back and forth. According to the instructions right on the spectrometer, to calibrate it, you look at a fluorescent light, and the fluorescent light has a very bright green line at 546 nanometers, and then you slide the scale back and forth until that green line is on 546. You can also calibrate it with the hydrogen spectrum tube using the red light at 654 nanometers. Because it already has a slit, you don't need to hold a slit in front of it to measure the wavelengths of something like this energy-saving fluorescent. You can just point the spectrometer slit, look off to the side over here, and you can actually see the spectra. This is admittedly quite a low-end spectrometer. There are other methods of measuring more accurately measuring the spectrum of a light source, and as you might imagine, they're hundreds to thousands of dollars more. I have a couple of them over here. This is a fairly old-fashioned, at least 25-30 years old, Prism Spectrometer. You can see that there's a prism in here, so that the light from the source is spread into its spectrum not by diffraction but by refraction. The way this instrument is used is there's a slit right here which can be opened to catch the light from the fainter spectral lines, or closed to sharpen up the line for better resolution, and the slit is put right up against the source, and this arm has a scale. And when it's in use, there's a light bulb that's put right here. It's a kind of source of white light, so that the light shining through the scale reflects off the front of the prism. And the whole thing is viewed, scale superimposed on the spectrum, through this telescope, which can be focused for an individual's eyes. So this actually uses reflection to see the scale and refraction through the prism to see the colors of the lines. Here's another instrument that allows you to measure the spectra of a light source. This is a spectrometer, a fiber optic spectrometer from Ocean Optics. This particular version has a master grading and a slave grading, which allows it to look at the spectrum over a wider view. The source, which is again our hydrogen spectrum tube, is right here, and the light is gathered by an optical fiber, and that fiber brings it to the master and slave channels. There's a connector here that splits the light so that it can go into both channels. And the results displayed on the computer screen. So here's that very, very bright red line at 655 nanometers. Here is the bright teal line. Here's the first violet, and then there's a little tiny faint violet here. This particular device actually can see lines all the way from 200 nanometers up to about 1300 nanometers. So it's capable of displaying some ultraviolet and infrared lines as well as the visible lines.